This is the problem that we're going to be looking at. It says find two non-negative numbers x and y for which x plus 3y equals 30 and xy squared is maximized. So the first thing that we're going to do is to find our m function, or the function that we're trying to maximize. So this function is going to be equal to m is equal to xy squared. So this is the function that we're trying to maximize. The next thing that we're going to do is look at this x plus 3y equals 30 function. We're going to take this function and we're going to solve it for y so that we can plug it into our m function so that we only have one variable. So we're going to take x plus 3y equals 30 and solve for y. The first thing we're going to do is take this x and move it to the other side. So our function is going to be equal to 3y equals 30 minus x. Then we're going to divide the entire function by 3 and get y is equal to 10 minus 1/3 x. The next thing I'm going to do is plug this y function into our m function so that we only have one variable. I went ahead and sped this up because it's just a lot of algebra. Now that we have this m function right here, we need to find the derivative of this function. The reason we need to find the derivative is because the derivative will show us the values where x equals 0, or the critical values of our function. These critical values are where we might find a maximum or a minimum value. To find the derivative of this function, we're going to be using the power rule, where you take the exponent of the variable, multiply it by the constant in front of the variable, and then subtract 1 from the exponent. So all in all, the derivative of our function is 100 minus 40 over 3x plus 1/3 x squared. The next thing that we need to do is set our derivative equal to 0 so that we can find the values of x that are equal to 0. Now that our function is equal to x, we're going to multiply the entire thing by 3. The reason we're going to do this is to get rid of these fractions so that we don't have to deal with fractions as we're trying to factor this equation. So whenever we multiply everything by 3, we're going to get 300 minus 40x plus x squared. This function is a lot easier for us to factor. Now we need to look at what numbers are multiples of 300 that add up to negative 40. So the values that we're actually going to get are x minus 10 and x minus 30. This is because negative 30 plus negative 10 is equal to negative 40, and negative 30 times negative 10 is equal to 300. So this is going to be the equation that we set equal to 0. We're going to set x minus 30 equal to 0 and x minus 10 equal to 0. And this is going to give us our x values. So our x values are going to be x is equal to 30 and x is equal to 10. The next thing I'm doing here is solving for the domain. The reason that we're doing this is because it's two non-negative numbers. So I went ahead and set that function that we had, y is equal to 10 minus 1/3 x, greater than or equal to 0, and then I solved it out for x and got that x is also equal to greater than or equal to 0. So we're going to have to use three variables when solving for our maximization. We're going to use 30, 10, and 0. So I went ahead and sped this portion up, but what we're doing here is plugging in our x values to this m function to find the value where m is the greatest. This is going to show us where the maximum value of our function is because it's the maximum value of our x values. So I went ahead and just sped up all of the algebra But you'll notice that as I'm going, you're plugging it into the m function, not the derivative function. You need to make sure that you're plugging it into the m function, not the derivative function, because we just found that all of these values are equal to 0 in the derivative function. So you're not going to find the value where your m is the greatest if you plug it into the derivative function, because they'll all be equal to 0. So as I solve all of these out, you'll notice that our greatest value is 10. So the value where x plus 3y equals 30 and xy squared is maximized is going to be 10 and 4,000 divided by 9.